Other than
Is everybody here?
I thought for myself.
We're all here. Better. All right, so this marks the last meeting to conclude our 15th year of the SIG. Wow. So thanks everyone for participating in this meeting live. So in January will be the start of our 16th year, trying to find some way to celebrate that. We're trying to put together a panel discussion around the topic of the future of software testing, and have some people that are interested in maybe participating in that. We'll see if we can round up 3 people to flesh out a panel. And so that's what we're tentatively thinking on. Get an email if you're on the mailing list, or check back to the QASIG.org site if you want to make sure. That's in January, second week, 6th Wednesday in January. So tonight, to wrap up the 15th year, we have an automation test engineer from Alaska Airlines, Ryan Papineau, who's been at the SIG several times, and also he's speaking tonight. So welcome.
Great, thank you.
Thank you.
So, as mentioned, Ryan Powell with Alaska Airlines. Today, here to talk about why testers can't test, and kind of our challenges we identified and solutions to those challenges. Before I get to that, I want to tell you about Alaska Airlines. Most of you probably heard of us. This is the hometown airline, but we have 1,000 flights a day that go to 100 locations, primarily servicing the West Coast, but we also do a lot of flights to Alaska, Hawaii, and now Cuba and Puerto Rico, I think. So we've got some new destinations online. We are an award-winning airline. We have won on time, the best on-time performance for years in a row. I think it's now the 7th time. And on top of that, for being on time, is actually just the J.D. Power Awards Best Airline. This is now the 9th year in a row consecutively. I believe winning in 6 out of 7 categories, or 7 out of 8. So pretty much all but one category being able to win the best airline. So, is there a question? Okay. This here is, in the center is our flight operations manager. This is the application we're trying to test. In the upper left, you can see we've got cargo. That has essentially the cargo data says, where do we storing cargo on the aircraft, how many pieces, what size are the boxes, how much do they weigh. On the upper right is baggage. Pretty much works the same way, how many bags people check. And then on the left-hand side, we have our passenger data, which are how many passengers and which zone they're sitting at in the aircraft. On the right-hand side is our aircraft communication system, which is essentially how the pilot kind of checks in for a flight and does pre-flight and gets that, I'll say authenticated, but validates as pre-flight. In the lower left, we have fuel. So when you look out in your wing, you'll see got some fuselage there. They're going to also store the main fuselage, or sorry, the wings or the main fuselage. And then other dependencies we have are like flight events. These are like the actual events that are occurring in real time. In the lower right, last but not least, is our crew. How many crew are assigned to that flight? Different types of aircraft have different crew needs. Well, once we started testing this application, we figured out that one dependency had a cross-dependency on another dependency. And as we kept going, that dependency even talked to another system. And before we know it, this application became very hard to test. So this is the 4 challenges. Actually, take it back to the next slide, sorry. This is the actual system we were testing. The previous slide is actually the candy-coded version to make it look simple. But as you can see, the system is complex. There are a lot of connectivity problems we need to solve and getting test data in the right places. So now getting back to why testers can't test. So we have our 4 main problems. First is the environment. It's shared. So if you're making changes to the environment, you're affecting somebody else. But likewise, we typically encounter where somebody else is making changes and impacting you. Our other problem is data. Data is a big one. Test environments are usually integrated, but not coordinated. One example is you've got like database A gets refreshed once a week, but database B gets refreshed once a month. So you have data that's not in sync. Services are much the same. They're typically front ends to databases, so they kind of follow the same problem. But sometimes that web service is a third-party one, and you don't have control over that. And then in our lower right quadrant, we've got events. For us, we're an airline. It's real-time events that are occurring, essentially logistics. So they don't exist because they're not cloned from prod, or we lack the resources to make them happen reliably. So, wanted to, before we get into the actual problems deeper, I wanted to talk a little bit about these event and service problems we're solving. First are our synchronous request responses. These are like your web services. So in our example, we've got our get cargo service, but then the system also needs to get data from our baggage. And then probably a passenger. And then we have last our fuel. Those are nice request, response, very synchronous. You're going to get an answer back immediately. But we also have those events we're talking about, which are asynchronous. So, such as the plane leaving the gate, then also taking off, and then eventually landing, and then also pulling into the gate at the arrival location. So this is just to give you context of some of the things that we were trying to solve for this environment. So how do we solve this synchronous request response problem? We use service virtualization. Service virtualization is not server virtualization. It is not VMware. It is not Hyper-V. It is virtualizing a request response. So as a request comes in, you can give a virtual response. So, is there any questions about that? I know it might be new.
Is it different from stubbing?
It's like stubbing, but it's more dynamic. So a stub would be like more like a unit test or just making sure you get a response. This you can do, record all of your scenarios. And this is where this becomes really powerful. So in this example, we've got our plane side device. If you ever look out the window when you're on the aircraft, you'll see the ramp agents loading up cargo and baggage. And they scan it saying, hey, it's now on the aircraft, it's in this location. Well, what we wanted to do was virtualize that dependency, because as you can see on the left-hand side, we have, it calls it the airport web service. But then we also, it is a service wrapper for more services, like our cargo service, our baggage, and our passengers. So what we did is we put our service and virtualization proxy in between the client and the server, and we ran through our scenarios, recording those request responses. We can now disconnect all that background infrastructure. Consider this as an IT cost avoidance solution. You no longer need those databases or those web services to give data back to your system under test. So now we're able to reliably run those exact same scenarios and get the same answer back every time. Any questions before I continue?
Yeah, do you test the services separately? Of this, like the 4 ones of that diagram?
Do we test those separately? The answer is yes, but we use the data for that differently. So what we're trying to do is actually test the client under test, which in this example is the plane side device.
Right.
What you're asking about is if we're testing that web service,
Yeah.
we would do that, but virtualize its dependencies. So
Right, okay.
in this example, we could virtualize the cargo service, the baggage service, and the passenger service to test the airport web service.
Okay. And do you actually at runtime use actual data from an actual scenario people find and record this data and do synthetic?
That is a very good question. We do, just high level, I'll answer, we do both. We either record real data if it's available, but going into my next sample, the data wasn't available. So we'll talk about that here next.
Okay.
Is data modeling. So in the example where the data wasn't available, one example is we were, our passenger data, we could not get that data in our test environment. It only existed in Pro. So what we did is we modeled it. So this is start with our main bit of data. We've got a flight. It's leaving from Washington, D.C., going to Seattle. And we're going to tag a passenger scenario to this. And it's going to be departing at 11:45 GMT. Well, as a request comes in, We extract that data from that request. We then use it to go look up to another table. This is our passenger scenario table. So now we can take that passenger scenario and notice the time. We delta the time for which that request comes in. So in this example, say the request comes in like a couple hours prior, comes in at 9:45. Actually, I just skipped a step here. So go to our minutes. The next column over is minutes prior to departure. So 1440 is like 1 day prior to departure. And as we go down, you can see we're getting smaller, getting 10 minutes prior to departure. And people are going through the 3 states, either booked, checked in, or reported. And we have the counts. So as we see time going on, people kind of drift from booked, and there are now more people checking in, and then finally people are boarded, and everybody's in the aircraft. So using that same example of D120, we then look up that seating scenario on the right to our seating scenario table. So in this table, we have what seats are available and who's in those seats. But now we get to change the status of that by doing a 3-way join to these 3 tables, which then sets it for there to be 6 booked and 4 boarded. So this is service simulation. It's a lot more effort to do than service virtualization, but it is wildly powerful. Using this technique, we can now simulate flights getting more or less passengers, where they're sitting at, and what the state of their is. Our next area is event modeling. We're talking earlier about the asynchronous events that occur, and when they happen, this is how we solve this. Using the same flight, Washington D.C. to Seattle, it's leaving at 11:45 GMT and arriving at 17:30 GMT. So we've got a departure and arrival time. What we do here is we model the events for when they should occur. So when should a plane depart? Well, in relative to its basis, so it's based off the departure time. When should it shift, which is our minutes on the right-hand column? That's how much we're going to shift it. So applying that, it'll depart at 11:45. But then we go to the next row, which is it's taking off. Its basis is also depart, but now add 5 minutes to that. So it would go off at 11:50. So now we have our input data and our model data. We take and essentially apply the model. It's essentially this data times the model gives you a nice generated data set that automatically shifts the message time. So now you can get the right event that's all data driven in the right place at the right time, the same like the scenario you need to do. What's great about this is going to our next piece. Actually, is there any questions about this?
So how do you validate kind of your event matrix there for inaccurate data?
Oh, we did a lot of analysis. So we actually had access to at least the basic prod data where we could actually analyze different markets. So we could say, prior to this market, we could do a diff of departure time. Actually, this example, so departure time versus takeoff.
Yeah.
Airplanes in the industry, it's called OOI, O-O-O-I. So it's out, off, then land, on, and then in. And so we can do essentially do data add between those, so we get an integer back to say, hey, here's the kind of how things flow. Different markets do behave differently, but for the sake of the testing, this worked just fine.
So you're using real data then to model that?
We analyzed real data to do it. We actually didn't record it.
Okay.
So because doing this would give absolute precise control.
Sure.
Because here's an example. So this is the sunny day, everything working perfectly. We're now able to say, hey, I want to make that flight be delayed, or I want to land 10 minutes after it's supposed to, or I want to suspend the event, or do a, what's it called, irregular operation. I want to divert it. We can now take this nice model and then totally adjust when things occur. Was another question over here? Never mind.
Quick one. Great depth and capability. Have you guys measured the cost of testing or quality in terms of the sustainment of the system? In other words, if the rate of change comes at a certain rate, then you're going to hit that coffin corner where, okay, the cost to maintain integrity on this might then equal, okay, this is too complex for what we need to push through. Have you guys gotten to that point?
We haven't analyzed it directly, I don't believe, but I have a really cool slide at the end.
Okay.
I've got a cool data point I'll tell you about that's really, there'll be a slide later I'll call it out for you.
From a business perspective, I can tell you that there's been numerous occasions where this was applied, and the fact that test scenarios could be refreshed and turned around within a matter of half an hour.
Sure.
Where, 2 or 3 occasions of that have more than paid for the fact that if you would have to set that up manually, and the resources, the different resources that would play into that, have more than made up for the fact that on those scenarios where we refreshed the environment and we used it for training purposes and we've used it for rollout testing, have made up for all the investment.
And iterative changes to the virtualization container model as well, saying these are the new feature sets in concert
Yes.
to support. Got it.
Yep.
Cool.
I'll add some more to that in a little bit. By the way, this is Nils, my man. I don't know if you've met everybody, but this is my manager for to oversee this project. So
Nice.
So to answer the previous question, we're able to shift and change, delete events, and also add new events. So it's really customizable. Now we've got that nice event table. That's our data model on the left. We then data pump that to our data engine, which now orchestrates all those events to the systems on the right. Now mind you, we only talk about flight events, but we're also doing other events that, such as the pilots checking in and doing their pre-flight, and also the gate process, such as the gate agent loading everybody on their craft and doing it's called post-departure closeout, saying everybody's on board, these are final numbers. And so it's actually orchestrating through a lot of different protocols here. It's either doing database updates, hitting web services, or doing message queuing. Any questions? So our other challenge we had was the test data. That was our biggest one. Mm-hmm. So here's a sample table you'd see on a lot of our databases. Essentially it's our flight number, the date, the city pair, and when it's departing and landing. This data kind of exists everywhere, all over the place. So what we did is we used test data management to solve this problem. Actually, let me phrase the problem a little better first. We grabbed 1 day's worth of data, and we lived through that data. Well, that data is all perfect, but now we want to use it again tomorrow. Well, tomorrow's data is different than today's. What we're able to do is grab this data, so we have it captured, and let our test data management tool identify all of the date time columns. Now we want to use it tomorrow, so it applies a date at day +1, and it will take us from October 5th to October 6th. It will then take this data refresh and pump it to all of our applications. So actually update all this and bring all the data back in alignment. Why this is awesome, it's also more IT cost avoidance topic, is we're only capturing 1 day of data. We're not loading the entire years or historical metadata that exists in the system. Therefore, it's really light and fast to restore. This process here for it to essentially do the ETL, to take that capture, transform it, and reload it, takes between 5 and 10 minutes. So now all of our data is now refreshed for the next day. That makes it really fast and be able to get back going in business.
Do you add anomalies into this?
We do have some capture anomalies. So some examples are like, let's say, for example, fuel too high, fuel too low. Because what will happen in the flight operations manager will actually throw alerts saying, here is some data that's not in the correct state.
But what about like a flight from Seattle to SMA, right? Typically, that's on time, but sometimes it's 20 minutes early, right? And so
we actually have it's kind of from the previous step of this step. We actually, after we load it, we have some massage scripts that actually go out and apply those updates. We'll actually insert our merged data that makes it like makes a cancellation flight at a certain time,
Okay.
or we'll actually date shift, like our international flights have an extra window of time that people have to check in at the airport. So we actually date add minutes to international flights. We also purposely disable some events for some particular flights that testers want to use, where only they control the data.
Okay.
So what we do is we essentially disable it from the automation to go fire those events, and then they have complete control. They can fire those events manually using the techniques that they use. Okay, now we're going to start bringing everything back together. We kind of touched on our problems and our individual solutions for those, and this is how we brought it together. First is we created a new environment that we put all our applications in that support our system under test. We call this environment CERT, short for certification. And here we use VMware. So, okay, new environment, we use VMware to virtualize those servers. Next, we use TDM. So a lot of those systems are all database oriented. And we used test data management to use that to solve that problem. And we used IBM Optum. And the two issues we just, actually one of the ones we just went through, which are the passenger data, which is the service simulation. We use service virtualization from Parasoft. It's not called Parasoft Virtualize. And across the bottom, those real-time events that occur from the data, so the event modeling, we used Parasoft SOA-test. Well, we now recorded this traffic for it. This is the magic. This is the place where I want you to really pay attention. Something really cool we're doing here. This environment now has everything you want to do. It has all the right data, has all your scenarios. It is now pristine. What we do now is we now put those service virtualization proxies between our system under test and all of those dependencies. We can now record that data. Once we have that data recorded, we can now disconnect from that environment and take this data and route it to another environment. So now you don't no longer have any of those databases, applications, or web services going up and down. You now have a single point of information going to your system under test. Any questions?
Do you also do, with this system, or maybe this is a separate implementation of this, do you do like reliability tests? For example, suppose while the database goes down, or there's a hardware failure, or there's too many requests, load network, something fails in a request that you represented with the green hexagon there.
Negative. That kind of reliability testing would just be done in an actual real environment, because we now virtualize this.
Right.
But, I mean, you could, but we're not using it for that purpose.
Okay.
We could go, what we can do is we can apply profiles, performance responses, so like for performance testing. We use it for that, but we don't purposely make it die. That's kind of the reliability side of the fence.
Okay.
But you totally can, we're just not doing that with it.
Okay.
Yeah, good question. So now we've kind of talked about a high level. I actually wanted to show you the UI of this, what we were testing. So down the left-hand side are aircraft. There's the tail numbers. I don't know if you can read it quite, it's kind of fuzzy.
Mm-hmm.
And across the top is time in GMT. And the blue rectangles are individual flights going from point A to point B. And the little black area between is people essentially deplaning the plane and boarding for the next flight. Well, imagine if you're a tester and you want to test this flight out here later in the day. You gotta wait until later in the day to get to it. Well, once you get that later in the afternoon to test it, what if somebody else needs to use it? So you've got contention sharing with other people. What if it gets worse and you find a bug and you have to wait till the following day to retest it?
Mm-hmm.
That presents kind of a problem, doesn't it? Does anybody else have that kind of problem in their environment? They burn data and have to wait? So here's the magic of the previous solution we said. Notice for the previous solution, we recorded all the data. Well, now that it's recorded, we can take that one scenario and make it run all day long. So that data clone is the exact same test case every half hour in the system. So that means you don't have to wait till tomorrow. Other people can share it. So now this creates a lot of scalability for our testers to test the system.
So
This
Oh, I'm sorry, question about that test case being repeated. Now, is the only thing that varies is the timestamps
Yes.
and the time context?
But all of the passenger, cargo, and fuel data, all those data points that essentially affect the weight and balance of the aircraft
Yeah.
are all identical. The only thing that changes is the time.
Okay, and it's Groundhog Day for all those cartoons.
Yes!
Okay.
That's what we say internally, but not really as a reference to people that aren't from, yeah, perfect. So what's beautiful about this also is the business came to us and they're like, we were going to train the users, the frontline employees. I was honest to God, this is true. Surprised. We had the system up and running, we knew people were training with it. It wasn't until after I presented at Star West last year that I came back to gather more info, like, hey, there's interest in this, let's get some more data. 3,000 employees, frontline employees that help operate our airline have been tested, have been trained using this exact environment. And they recently wrote it up in Aircraft IT magazine, and they cited this ability to essentially create the data that can allow them to train for it. So when you hear that we're an on-time airline, our frontline staff train repeatedly, consistent scenarios, and know how to handle things that the old system would not allow them to do. So we take great pride in being recognized externally from another magazine that for what we're able to accomplish. So that actually pretty much sums up the presentation. Just pretty much open it up for any questions you have and challenges.
I have a question about your last slide, and you have about a dozen different scenarios there which you're repeating. Does that include not just happy paths, but also little funny, like
yes.
I don't know, the passengers get in a fight, they have to take off the plane, now the plane's late.
That one isn't covered here, but that's covered elsewhere. No, actually, to the point, the ending of this is what's happening here is there's other operational things that happen. So for our cargo planes, there's things called pits. So they actually, there's things called igloos, where they can, we only have like 5 of those planes in the fleet. We're able to clone those now. Because it's a very distinct scenario. That specific aircraft, we have 5. Well, we only have 5 of those aircraft. How are you going to get people trained to operate that unique scenario? We're actually now able to take that and give them 20 or more. Whatever they needed, we could provide them. But going back to the regular operation piece didn't exist here. We tested that elsewhere because they were trained. They would fire the events themselves. It wasn't pre-built in because essentially the instructor could say, "Hey, I'm delaying this flight. Now you, as the trainee, need to respond to what I just did to you." So. Yeah.
So you can kind of, as you were saying, you clone off the scenarios so that people aren't conflicting with each other in the different scenarios.
Yes. So
and is that happening over different VMs, or is it kind of what's
environment?
Okay.
So this is mid-log, and this is a shared environment. And what they want is they would have I think 10 to 20 people at a time doing the training session. Our one challenge was that, hey, that one flight's later today. They're like, well, I have a classroom of trainers who have 3 hours to go through this drill,
right? And
we want to get them, trained on it. They would actually give these different tales to the different people attending the training. So this is really this keeps on scrolling. Like there's thousands of, but it's really primarily the amount of scenarios they gave us to train on. And I heard some very surprising stuff. Like they have people that train on in the middle of the night. Sunday mornings at 7 o'clock.
Yeah, I assume your system, like you basically say, okay, now you're going to start at this point of the day,
This goes right here. I think the filter we have it chopped off, but this data can go all day long or whatever we clone it to.
So they may be training for stuff happening at 5 in the afternoon and doing it at 2 in the morning.
Yes.
It's all kind of time shifting.
So there's a lot of time shifting stuff, and actually I got another special guest here tonight, Jeff back here in the corner. He's all that TDM you saw. He does all the test data stuff. It's all him.
Nice job.
Yeah.
Could you give us sort of high-level description of? I mean, you have sort of arrows and stuff, but I'm not sure how that translates to sort of what roles testers are filling. And then before all this magic was put into place, how did you test this stuff?
Okay, so the old story was they used to clone data for production. Data in production is unreliable. And if you're saying, I want to test in a regular operation today now, you're not going to get with production. We're an on-time airline.
You just get whatever,
You get what's there.
what's there.
So we'd have subject matter experts who would then go tweak the data the way they wanted. So it was a lot of, when I said access the resources to make the events occur, we actually have the tools to simulate, to do all of this. But that means now you've got one SME that knows how to use that tool. They're assigned to the project, but now it takes them time to do it. But now you have a whole test team of like 10 to 20 testers trying to test this, but you need to scale up. So what they first did was train those other testers how to use those tools. Well, that's good to get those events to occur when the tester wants. But what we want to do is have it happen all the time with no person behind the screen making the strings go. But actually, it's built into the automation. If you want that event to occur at that time, it'll occur at that time.
So that add data, or that add date stuff, when you're talking about take one day and add date, that's literally replacing a human being going in and changing dates or whatever, changing times, whatever.
And when we insert data into that, so there was a piece of this. So when we first started out, we loaded sections of prod that we could in. And we use test data management, another tool it's got called obfuscation. So I don't know if anybody's here. Does anybody here use test data management? Okay. You're using an off-the-shelf tool, or you do build your own scripts?
Sometimes we have to do our own scripts because the data and the interfaces are in-house as well, they're medical.
Okay.
So we've got to obfuscate ourselves. Plus, even the tool itself has to be FDA compliant, so there's some reasoning.
A lot of regulation.
Yes.
Okay. So we use a similar approach. We use the tool for some of this work, and we also have a lot of custom SQL scripts to do some of this work. Like this piece here, you see, that was done using custom SQL. But we had already recorded it using other techniques. So it's kind of looking at the problem and figuring out what you want to solve it at. Any other questions? Okay.
I'm going to click a little deeper. I'm going to segue on what was just discussed here. What's the variance between your service model, virtualization and production?
We have two. So kind of what we have here is this was a record of production,
and I'm going to
smooth it out.
So I'm going to continue asking the question here. How much variance is there between the capability you've designed in this virtualization model and the way that features are used and implemented in production? And where I'm going with this is we design capability and we test to death in the millions the capability is designed, but then production doesn't, the users, the systems, the error logging doesn't use it the way it was designed to do. Just because you built the feature doesn't mean that they're clicking it and using it that way. The way that they get to the data to measure and count the number of on-check baggage that met certain weight and dimensions, you're telling the user, but that's not the way you're supposed to model that. How did you get to that menu? And yet that's the way they're using it. How do you account for that? Or do you not account for that here and make sure you cover that, saying, okay, what is production? What is the product and how it's really being used?
So this was a complete system complete. So what you see here is a complete application system replacement for an older one that was more complex. I honestly, God didn't see it. They wouldn't let me see it. They said, don't even look at it. We're going to use the new one the way it's supposed to be used. So this is a commercial off-the-shelf software inside the airline industry.
Got it.
And it's customized. So it's customized to the Alaska business rules. It's like I have our international flights. This market needs this certain alert to go off at a certain time. This is called a fail by exception system. So it's pretty much, if everything's going smooth, it's automated. But as soon as an exception occurs, there's actually another UI here too, that things will start lighting up in red, saying, hey, this needs attention. Like there's just too much cargo, there's not enough fuel. We need to have actually, does anybody here fly on Horizon much? So the typical thing is the Horizon planes are nose heavy. So I've flown before and got the same drill. The plane's full, it's fine, but if you get on a light load, or maybe not, it's a half, they've already got that alert saying you need to tell people we need this many people to move to the back.
Yeah.
Kind of way. So that's an actual business process that this helps orchestrate.
To your point too, another reason why the why the variance is very small is that we use that system, we use the data in those test cases as training material. So everybody that got exposed to the system, got exposed to the very test cases that, you know, people that the system was designed for. So they were very familiar with it, and that's exactly how they got to use it. So that was pretty much.
So a combination of that between off the shelf, the variance for
Yeah.
capability and functionality as intended is pretty small.
Yeah.
Got it.
A couple other points I want to say. So one thing is the same. This is like getting a little too theory, but testing, the scientific method, you will control. Then what's different is your test. What this provides you is that perfect control. This always behaves the same way. So on a day-by-day basis, our data didn't change on a day-by-day basis. The software did. So now you can identify software flaws much easier. Because if you're testing this day by day and you see something happen, you're like, wait a second, that's not supposed to be there. Either configuration changed or the software, or there's an environmental problem elsewhere, which we still run into. Not in the training environment, that was like near perfect, like for years. Actually, speaking about the years perspective, this recording was done on 3/18/2014. It's almost been going for nearly 1,000 days. Every day, same system going. So it's super reliable. Now finally, years later, we're getting some new aircraft that are special. Some Embraer E175s. So we're actually now adding some new aircraft. So it's just been totally reliable since then.
That kind of was my question, is essentially, you know, 1 days versus stuff. I was going to ask, how often do you refresh that, or you just keep appending to it or alter
We're
it?
actually, primarily, I won't say zero maintenance. It's only when they want data changed. So some of the data contains a test data management. So that's a little bit harder to update because we actually have to go to our TDM tool, take that snapshot aside and massage it to what you want to have captured on a day-by-day basis.
Okay.
But some of the stuff we can actually control outside of TDM using our own custom SQL. It's like that example where I said we insert flights or scenarios. That's totally, we do that outside of the TDM task. It just calls that custom SQL that shifts or inserts data. And there's another table we have for the passenger scenarios and the fuel. That's completely, the tester can just go update a column saying, I want to change the fuel to this number and do a test case. They change it once, and every day it'll stay to that until they change it again. So it's really, we've tried to put as much as we could easily into the tester's hands, but there's still, not saying it was perfect or easy, but there's things we had to do there was about a few months where we had to, since we recorded prod, we're like, okay, prod didn't have this scenario. We were working with them to say, I want to shift this to this, I want to shift this to this, change this. And so it was probably a few months of massaging all the data, pretty much from their requests of what they wanted the data to be like as we integrated into, and then that's just now in that state until we want to change. Yes?
So I've got two daughters that are going to school on the East Coast, and they're both flying back on the 20th of December. And there's a blizzard coming in.
Yes.
And on the write-up about this talk, it's
yes.
You guys plan for that doomsday
yes.
Storm coming in, and how do you guys plan for that?
So how
Well, are your daughters flying in on Alaska?
Don't try to say here. No,
Because, you know, then they'll be covered. Then, they're covered, it's in the right cover.
So what we did is, remember earlier on we had the data engine. Go fast enough. Right before this, right about here. What we did is, once this was data feeding, flights running normally, we actually took and started canceling a lot of flights. So as you asked if we were doing the exception, we didn't do this every day. We did run through the scenario where to simulate a snowstorm in July. The whole point of this is that's test data that testers want to test because you can't get to it. It's hard to get to. When you're in there on-time airline, you can't find that as delays and cancellations. So by using this system, we can now fire and start flipping all these different flights to delay and cancel and cause these problems. So we did simulate the quote snowstorm in July once. Once you've got that control data, you can do that.
So my experience has been that Alaska is not on time, but ahead of time.
Ahead of time.
Yeah,
Yes, very, very typical. So, I mean,
Are you flying early in the morning?
No, so I give you a perfect example yesterday. My girlfriend flew in from SNA, and flight was supposed to land at 6:38. Landed at 5:58. Okay, it was 40 minutes early, right?
Okay.
It left the gate. Actually left the gate per flight track. It left the gate 10 minutes early.
The
And
earliest,
SNA is pretty
Yeah.
small, right? So,
yeah, actually I love flying out there because
Yeah.
it's so easy. I can walk it off the street and TSA.
but it left the gate 10 minutes early and took off 5 minutes early, right? So I mean, clearly like Boston, right? Wasn't great for her because I was stuck in traffic. But she was stuck at baggage claim. But like that's an event, right? Like
Yes.
and clearly like
We can ship that.
Yeah.
Exactly what you
So
described.
how do you walk through how do you do that?
Okay,
How
so
do you
this generates
generate all those
this is
events?
perfect. The question, we have this perfect answer for this. So this is the sunny day generated data. So imagine this. I said we have 1,000 flights. Well, it's really 1,000 of these. And when you see these events, it's actually about 30 to 40 of those. Everything I've presented here is it's nice, simple, easy to digest, but every aircraft, it's about 30 to 40 messages, depending if it's Alaska or Horizon. And generates this data set. It's around 100,000 rows. Is that right? I can't be right. Ballpark math. So with all these rows of data, what we do is we can say, go update. This is a SQL database. So our update statement in our TDM calls this patch up script, which will say update set message time for those events that you're interested in. So for your particular market, it would be all the DCA Seattle, this example. Update message time, do a date add hour +1 or date add minute +10. So that when it goes to the next step, that actually happens after the TDM load, massages it, then the automation engine pulls in that data set and starts iterating over it. So that's how we do that exact scenario that you do. We do have that in it.
So like landing in Seattle, like that gate that you was going to go to may not be available, right? And like if that flight was turning around and going back to Palm Springs, then now like the amount of time it's on the ground in Seattle is longer, right? And then so how does that all get modeled inside of here?
So we actually we don't simulate all those in this. So what we did with the testers model. So the example we had where we wanted to make things occur, we didn't do it across every single. We only did it on every discrete test case they wanted. They said, I want this on this flight this time. It'll be that way every day. We didn't go collectively across the entire fleet in I call it unwinding the onion, or to now have more time for that aircraft at that location. But we do have some unwind onion scenarios that we've tried in some other environments using different types of data. We have a whole lot of data that we play with.
So a lot of these tests were focused on weight and balance scenarios for the airplanes. What you're describing is a typical operational type scenario. And it's interesting, I've sat in many planes because you take off on time and you're like, all right, cool. And then he says, we're gonna land 20 minutes early, like, yes, great, I'm gonna catch the bus and be out of the airport, only to come landing 25 minutes early, but there's no gate available, right? So this is the problem about landing early. The gates are all synced with the planned time. So you may come in early, but that doesn't mean that your gate is available yet, right? So, you sit that time on the tarmac to just come in on time, so to speak. That's one of those operational scenarios that has to do with the congestion of the SeaTac airport and the expansion of the terminal that they're going through, and hopefully we can solve some of those issues.
So just to add to that, so that's why, I've noticed it, I don't know if you guys, but usually at the airport, not always, there's been a few times, always hear a gate change for an Alaska flight because it did come in early. This actually happened, I think, actually at SNA once, and also in Oakland, where they're like, hey, this plane's been moved to another gate. So we could simulate that, but we don't. The goal here is to handle the weight and balance, because that's and also the delays, because that flags that UI to behave differently.
So I have a question. Could you show a complete dependency diagram or deployment diagram for the flight manager? Because I'm trying to wrap my mind around what exactly are you testing here?
Okay.
Simulated or
in a
quasi-simulated
nutshell,
data?
let's just go back. a little bit of
There it is.
display.
Simple.
There we go. This is the simple one.
Yes.
So this is our flight manager in the middle.
I'm sorry.
All these interfaces, so a lot of these, like on the left side, are flight events. So there's the leads we're talking about. There's a whole lot of other ones. There's maybe another plus, like a delay, a cancellation, a divert, a flyover, a return to gate, diversion. Like there's another flag stop. There's a whole bunch of different types of events. So those kind of come through here on the left.
How many different tiers are represented here?
Okay, so we use essentially a pub sub model for our events. So one event comes in for the airlines, okay, that GUI event. Could be way over here on the left. Let's see here. Can't tell, it's blurred out for purpose, but effectively that event fires comes in here. What kind of event is it? So there's all these rules that say, hey, I need this data from it, I need this data. We'll then do a transform to get the data in the right format. So I don't know if you guys do a lot of interface testing, but so our client, our system under test needs its data in a particular schema structure. Our airline gets the event, well, hey, we have this structure. Our pub sub engine actually takes that data, restructures it so it matches the schema design for our application under test, and then flows across this is like a message queuing layer.
I'm sorry, can I redirect a different question? I mean, how many different tiers and how many different software packages are being redeployed and features added or bugs fixed?
Okay, so
Impact on
this one is just a single application. It's our flight operations manager. But out here on the edges, you'll essentially see like our cargo system, our baggage system, our passenger system, crew, fuel. There's another system, which is our aircraft communication system. So that's what I'm up to 6 now, but I think there's about 10 plus. There's like, so some of the systems are 2.
Right.
So here's cargo is actually 2 systems. So we actually have a section that goes regular cargo, but if you ever fly with a pet, like, pet, so you have a live animal and a carrier, that kind of data flows through another one, but it still all comes in on the cargo side of the fence.
Wow.
So those are like little background information of like how some of these things all feed together. And then up here in the upper right, you'll see that's the passenger, just like the tool that the ramp agents use. So we've got also the aircraft communication system floating around here somewhere. So there's a lot of things that come into play for these dependencies to come together.
A lot of different tiers. There's the wireless and wired communications.
Yeah, so that actually comes in externally from one of our vendors for that. Because I've been for Menzies. So Menzies are essentially the ramp agents contact at the airport. So
Okay.
we provide this system, but it comes in whatever system they use.
So is there a failure in the system in these 10 tiers, for example? What kind of information do you get on a few slides later you have, say, a failed chest represented in red?
Okay. Okay. So say if system here wasn't like sending data in or was bad.
Yeah.
We didn't do that exactly, so we should do this right. We would have it in our data set. That's what we wanted to test in that system. It's there. But each of these systems also test on its own as well. So here's an example. We use TDM, which are we've got the databases. You see databases around. Those applications sit behind that database. We'd have our whole separate set of automation that would test those like web services that sit behind those databases. I don't know if that.
But, yeah, it does. I'm also wondering where are the most likely causes of failure, or how might a failure cascade?
Okay. Our typical failure we saw were in our pub sub engine, because we're still living in a test environment.
Yeah.
We would see things get stuck, just like that system. As soon as you still have an application, the application can misbehave. And so for our flight eventing, those are the ones we typically saw errors on, where it's like, don't know why it got stuck, but it got stuck, and then it go bounce it. And then all your data now shows up, so it's like sitting on a queue, but it wasn't reading the queue anymore.
Oh.
So that's happened before, but it's not like, it's not that you don't work, but it has happened.
Yeah.
So that's why when I said, here's the magic, you get rid of all of that, and And our true recorded virtualization piece operated on all those little spider legs, putting our application under test.
Okay, I'm sorry, there's comments about that, so. And you said that you tested the services, the virtualized services you have here.
Yeah, separate.
Yeah,
So those
yeah.
services that float out here, we have like service wrappers. So one service calls another service.
Mhm.
That dependency, we would, not always, but we'd either use TDM or we'd use service virtualization, depending on what problem we're trying to solve.
Yeah. Thanks.
Yes.
So I assume you have some moderately stringent certification requirements or
FAA
something.
regulations.
There's a regulatory
Yes.
body involved. How do you convince the FAA that your new approach is, you know, at least as good as your old approach and, you know, doesn't miss anything that your old approach caught and checks all their boxes?
That's a very good question. So the new system, since it is commercial off the shelf, they're used to the FAA regulation. They have a FAA audit piece. So so this is essentially solving the flight plan. Our flight operations manager generates a flight plan for a particular flight. Has all the inputs for weight and balance, how many people, the cargo baggage fuel, and figures out the two kind of bits of data is essentially the center of gravity.
So where to burn the fuel from and where to put the people in.
Precisely. Well, but it's also there's other data that are like, hey, this is a long flight, we're flying out to Hawaii. You're gonna load up not just fuel in the main fuselage, but also the wings as well. But a shorter flight from like Seattle to Portland, you're in the air for 20 minutes. Just gonna load the fuel into the main fuselage because those little time increments save us because you have to have that fueler go hook up to multiple locations of the aircraft. So there's all these optimizations from the airline for understanding weight and balance that are useful to make us on time and really understand not just the data, but the operation that it takes to run an airline. I've heard from previous stories how they used to do it previous to the old software. They used to do it by hand. And the big thing was, there were some tourist fans in here, they would fly, all the students would fly over to the university. So they would know, like, oh my God, we have a ton of bags today, we need to recalculate and load fuel in this because they're doing it by hand.
So like start of the school year.
Yes. So at the end of the school year, everybady's flying.
Christmas, they'd all fly back and leave their bag, and they would bring all their stuff.
They'd take all their stuff, they got the Christmas bag with them. So they would know. In the old system, they're like, oh my God, I've got to recalculate all this.
So then as far as the FAA goes, the system you're starting from, the new system you're starting from is off the shelf. And then you said you modify it to conform
customized rules
with your, but those rules are not new rules. Those are the rules Alaska has had since forever, which the FAA is presumably already comfortable with, or they would have told you to change how you operate your plane. So hopefully those two pieces come together, unless something horrible happens trying to merge them together. The FAA is like, well, that's good and that's good. So these together should be good.
Yeah, so what it is, it essentially generates a FAA audit report for every single flight that finishes the flight plan process. So it actually stacks by the queue. And they actually, I don't know the precise numbers, but I think it's like 3,000 plus have to go through this process. I mean, if you think about it for a second, that sounds about right. Testing the software for 400,000 flights a day.
Right.
Essentially, you test your software for 3 months, and then you would have that many flight plans that they run it on.
Awesome, thank you.
Yes?
Does it heavily impact your testing processes when new regulations, for example, the lithium-ion batteries over the last few years, how does that affect your processes when something like that happens?
So that's an onboarding, that's a passenger-facing process, because it's essentially you've got your phone on you, because all of your cargo baggage is like stored in the cargo hold. You don't have any, you're not going to take and put your phone in your bag. In theory, you could, but shouldn't. Stay banned now. But for this, there are other rules for what's it called? There's a whole plethora. When you say there's a rule, there's like 20, 30 plus different codes. Like example of one is, which has an animal hold. It's a business rule for ABIH. There's another one for the batteries. So
okay, so you already have existing rules for those scenarios.
Yeah, so an example is for batteries, wheelchairs. There's like multiple types of batteries that drive those, and those each have their own code. So that when they load it, it's flagged, hey, we have this type of cargo here. But Another one is actually, big problem is Alaska. A lot of people will get fish or meat and stick it in, you know, carbon dioxide. Yeah, so you don't want to have an animal in the cargo hold with that. So it'll flag up an alert saying, hey, there's an animal, and you got CO2 coming off this dry ice. Put them in separate areas.
Oh, okay.
So there are rules like that as well. There's a whole lot of other rules, but so those are the kind of things that the testers wanted in the system. We put it in, and then we can have it reliable day over day. Because in prod, the next day, there may not be an animal on cargo hold. That's what made it so fun to test. We just now made it consistent. Any other questions? All right. Well, thank you for coming out. We wanted to do door trials.